Yeah, welcome. I'm Michael, as everyone knows. And Anthony, thank you for joining the two of us here on the show. Happy to have
Yeah,
you.
you're welcome. Yeah, I'm glad to be here.
Well, I want to kick this off with an interesting article. It's by Tom Christie, titled "Python Async Frameworks Beyond Developer Tribalism," and I, uh, I think it's a and Tom Christie. If you don't know who he is, he's done some things like the Django REST framework and HTTPX. Of course, other people are on those projects as well, but bright guy. And I think it's in part to a reaction. We didn't cover this article, but we noticed it prior. An article called "Async Python is Not Faster." But all of us had some issues with the article itself, and so this isn't a direct rebuttal, but it's an interesting read. One of the things Tom Christie's pointing out is just that I think that we need to move the Python community beyond polarizing discussions and I think the async Python is not faster was not a helpful discussion, uh, but it's part of it anyway. A little bit of a quote: "We could probably benefit from a bit more recognition of where there is shared ground, and uh, and in the areas where there's less clarity, have constructive conversations around those." And so some of the shared ground Tom points out is um, kind of one of the things is you really shouldn't really care about performance too much when you start a project. The success of a project is more related to developer experience and the strengths surrounding the ecosystem of the framework you're using, not just whether or not it's faster. Um, and you should care, but we as the Python community do need to care about web performance because partly because um, other projects, new projects starting off might decide to go with a non-Python solution because they fear Python might be too slow. So that is one of the
Brian and Anthony, how often have either of you heard, oh, we decided to rewrite that in Go so we have proper async, or we decided to use JavaScript here because it supports async through Node or something like that? Like I've heard that a lot.
Mm, yeah, definitely. Lots of projects.
Yeah, and I'm not sure. I don't know anything about those other languages though. So, I mean, I at least I haven't used them. But for me, it would be a mistake because I know Python. And I don't know those other ones. But okay, so that's one of the points that maybe we should care a little bit, but also we should be careful about the word performance because if you measure performance as just a single async function calls with or a single function call, an async call is going to be slightly slower because there's a little bit of async overhead. But we don't use async because we want single threaded applications to be faster. We use it because especially IO bound concurrent tasks they scale better with async. Um, and the other aspect we wanted to talk about was there's just really you have to you have to be careful with looking at benchmark data because um, benchmarks are often geared to selected to tell the story that the person writing the article wants to convey, and
Or the
they're
situation that
just not
they're trying
fair.
to solve, right? They're like, oh, I thought this would help. I tried to solve with this. Turns out it doesn't. It must be bad,
Yeah.
right?
Um, and then okay, so there's some things that they're just reasonable statements, and there's some valid differences. That there's like for instance, should the web frameworks we have now, should they start converting to async, or should we just leave them as they are and develop new frameworks that are async native? Those are some differences. There's also different approaches, which is part of the confusion and part of the discussion. Is there's async IO, there's also Trio and Twisted and Curio, and how to decide which one. It does take um, there is some confusion there, and I think that's valid. So the discourse and the discussion is important, but I think it's important. Tom points out to say basically we need to keep it the benefits of adopting genuine collaborative mindset are good rather than a competitive mindset. So let's not fight with each other. There may be different or everybody's working on different little corners of the landscape, but we're still trying to appreciate move async and move web forward for Python. So anyway, stay positive, be happy.
Be happy, man. Well, I didn't want to just call this other article out and criticize it because I don't think that adds a lot of value. I don't think we want to cover items just to criticize them, except for their rare moments where it's getting a ton of attention. And if you think there's an inaccuracy, you probably should call it. I'm glad Tom wrote this article. I think Tom wrote it, right? I mean, it's not attributed, but it's from basically his organization. So
yeah, I had to go look at the GitHub repo to see who did the push, the commits for this article. So yep, it was Tom.
Well, what an interesting way to attribute it. Very cool. I honestly believe that other article, which you're linking to, is inaccurate. I think it's trying to apply async to a situation where it's not very warranted. It's like this hammer is really bad at unscrewing this nail, or this unscrewing the screw. Hammers are bad, right? Well, hammers aren't for that. Async stuff is for scaling when there is a waiting period, when there's a latency when you're waiting on something. And the setup there was the DB was 100% maxed out. So there's no way to like push that waiting and get more out of the database. And there was almost no waiting, like a few milliseconds anyway. And so the overhead didn't make any sense. Somebody wrote me and said, Michael, please, I gotta know your thoughts on this. So I went ahead and did a little quick test. I've got in my async course, I've got some stuff where we go and talk to things on the internet where there's like ping time latency and stuff. And it goes and gets 10 items off a web server. Ping time's like 100 milliseconds or something. It was 750% faster to use the async version than not the async version. I changed that number to get 100 of them, and it went from 50 seconds, almost 1 minute, down to 2.5 seconds, 1,750% faster. Async is about scaling the waiting part. If there's no waiting, there's no benefit. There's just overhead.
Yeah, I mean, the one thing I have to, I guess I'm going to be on the other side a little bit. The async is not faster article. One of the things you did point out was a lot of the async framework benchmarks and the benchmark numbers are not really that fair because there's other ways you can speed up the other platforms by, for instance, adding processors or CPUs, adding more cores to different applications, and that maybe the original application was just misconfigured. I think that's valid, but it doesn't mean that async is bad. It's just
it definitely adds some complexity. Go ahead, Nate.
I think if you're comparing it with multi-threading, I think that's the comparison. I think if you're just looking at I've got single sequential code, does adding async make it faster? If it's something that's IO bound, yes is the answer. But if you're comparing it to multi-threading, so using the threading module to spawn threads, then I think that's where you see the performance improvement. So I've got some like micro benchmarks doing like TCP port scanning across all the different ways you can do concurrency and parallelism in Python. And async was the fastest of all those options. And it cuts down a lot of the overhead from threading because the way that threads work in Python, they've kind of got this bootstrap module that kind of has to load some of the stuff that it needs for context. Whereas async doesn't need that. So it kind of cuts down a lot of that overhead. I think one of the challenges I've had with async in the earlier versions where it got released was the amount of boilerplate code and kind of like infrastructure you needed to put in to just to do something really simple, which is like, I want to run this function asynchronously. Like, I don't care about how the event loops and all that kind of stuff. Like,
I want to kick it off and forget it. It's like, why can't I just call this function and let it go? What is all this stuff I'm doing?
Yeah, exactly. So like I've used other languages where the async is a bit more fluent. Like it's I've been using the Kotlin in async last week, and I've used .NET or C#, the Task API, which is really, really nice to use. And it's a bit you like the other challenge is which bit of code owns the event loop. And that's like an anti-pattern where you end up with, like a God class that's kind of doing everything. And you've kind of then got to think about how you factor the application so that, okay, which bit owns the event loop? How do I construct that? Where does it end? We were help on the Real Python community group. Somebody was asking some questions. They'd added async or as a multi-threading into their code. And we were just trying to get them to refactor it to take all the logic out of the function that was being multi-threaded and put it into the master, and just put the minimal amount of code in the threaded function. I think there's still a whole bunch of stuff like that which people need some good learning on, and they need to get used to. It's like a different way of writing code. It's not just something that you can sprinkle on top, and it just suddenly makes your code faster. I think that's part of the misunderstanding.
Yeah, especially in Python, where it takes that extra step of you got to manage the loop and then you've got to run it, and it's not like kind of I've kicked off a bunch of stuff and now it's all just happening.
Yeah, they made that simpler in 3.7 and 3.8. They've kind of got some shortcut modules that so I think it's now like 1 or 2 lines of extra code you need as boilerplate just to get async IO up and running. So it's a lot better than it was in the earlier versions.
But even if it's not a lot of extra code, it is and Tom Christie points this out, multi-threading and async are more complicated than not. So that's just a reality. Whether or not the code's too much more complicated, the entire design is different, and it's a reality. That isn't to say don't do async or don't do multi-threading. It's just you don't get it for free. So
I think almost the opposite in a sense. I think the code is not complicated enough. On the other hand, like it looks close enough that people don't realize they have to change their mindset and like approach it in an entirely different way. And they feel like, oh, I just call it this way now. But then they run into these issues. You're like, oh, this is broken. Like, why is this not working? Or, like you think you can just do it one way, but you really, if you don't have a little deeper understanding, you can just go down the wrong path also.
Yeah.
All right. Well, that was interesting. Thanks for bringing that up.